Hi, everyone. My name's Gwen. I'm from Indianapolis in the United States. And today I want to talk about a little of how React Native is a happy medium between native and other hybrid frameworks where you have an excellent developer experience like you have tools on the web. And then also you have a great user experience in the end, so you're not sacrificing one for the other, as in many cross-platform and other solutions. Here's my contact information. I'll show it again at the end. Just a little bit about me. You can find me pretty much anywhere on the web by Googling my name. My background in mobile development started in 2014 with Swift. I started learning Swift, wanting to build applications, and then I started working for consulting companies, so I would have to write for both platforms at the same time. We used a variety of tools. We did Cordova, Ionic, PhoneGap, things like that. The performance was never quite there. It never felt like a truly native application as it did when I built Swift applications. And yeah, I feel like we were sacrificing one thing for the other so we could share a code base and build things more quickly, and especially when we were building mock-ups or prototypes to send to a company and things like that. So then almost 2 years ago, I found React Native, and I had already used React for the web, so I was kind of used to the paradigm, and I loved it. I love it more than I do React for the web. It makes a lot of sense to me. There's a lot of different benefits that I'll get into later, but it made, I want to say, life easier for us in consulting. It let us make 60 frames per second user interactions and all these other things that we wanted from the hybrid environment that we would need to write in a native environment to be able to get. On top of that, one of the greatest benefits of React Native is being able to reuse my web skills that I already had learned from the web into native. So what is React Native? At the most basic level, it's a way to build mobile applications in JavaScript. It's cross-platform, so about 80 to 100% of the code that you write will be exactly the same for Android and iOS. It's declarative, so if you're doing things like animations and things that require a lot of compute, you don't want to be doing that all in JavaScript as far as the computation. So you can kind of write out what you want to do in JavaScript, give it as a command to React Native, and underneath all of these things like drag and drop features, stuff like that will be run in native for you. So you don't actually have to write the native code to run native code and get native performance. It uses the React paradigm. So are you guys familiar with how React works in components? A few people? Okay. So that's basically how it works. When you look side by side, React and React Native, it looks extremely similar, except obviously you're not rendering to a DOM. You don't have regular HTML elements and stuff like that, but I'll show a comparison in a minute. It's also learn once, build anywhere. So the idea behind React in general was that you could learn this one way of writing your JavaScript and components, and you would be able to build it on a lot of different platforms. So for example, now you can build it on the web, you can build it in mobile, of course, desktop, you can build hardware IoT applications, there's React VR, there's all these different platforms that you're not necessarily going to be reusing all of your code, but you'll be reusing all of your skills between the platforms. So this is basically how the React paradigm looks. The parser I'm using here highlights it a little bit funny, but it's basically you're using a lot of ES6 in React, so you have your imports at the top of the file, and then you define your classes and functions, and that's what you return and render to the screen and the view. And then you can make JavaScript functions, and you have your logic and your view in the same files together. And then you'll render it to the DOM or the view. And here's a very simple example of how the React paradigm works. This is just a button clicker example. So it shows there's some built-in methods with React, like the constructor function. Add is a custom method And then in the view that I'm returning, I'm keeping track of count on state, and then when I click on a button, I'm referencing this.add, which is calling my own custom add function. Oh, it's not scrolling on there for some reason. Yeah. So I'm calling my own custom this.add function, and then I'm rendering it to the DOM here. And this is almost exactly the same in React Native. So here is the same thing in React Native. I'm making the same kind of class, the same imports. The only difference here is that I import from a React Native API. So view and text here are analogous to a container element, like a div and an h1 or a paragraph tag on the web. And then I can just render it. I wrap it in a view tag or a container, and then I have text and just hello. And then instead of rendering it to a DOM, I render it to React Native, which takes care of handling rendering it to a native view for iOS and Android. And here's the same button example. The only difference here is that instead of clicking, you'll need to handle a touch event. So React Native has a lot of different ways of handling touch events by default. I'm just importing touchable opacity here. And then when I press on press, this is supposed to be camel cased. My parser is making it lowercase, but so on press it runs this.add, and it will set state and add 1 to the counter. So it's almost exactly the same. You just have to account for things that are different inherently on mobile screens. And then, of course, you'll render the component to a native screen. By default, React Native also uses a lot of web APIs. So it uses a Flexbox API. By default, it'll display everything in Flex. Flex is a more modern way to lay out web applications that they made, because there were so many problems if you've used floats and that kind of thing before. Then it was just a nightmare to lay out web pages. So they made it as a more modern way to, because people were using more and more complex layouts, so it didn't make sense to use something old-fashioned. React Native took this intuitive design and ported it into React Native. So you have display flex and flex direction column, and these are by default in all your React Native components, which I'll show in a second when we look at an app. So here are some of the benefits of React Native that companies and people find from using it. You get a lot of code sharing, as I said before. All of your UI views are actual native UI views, so the look and feel of them will be exactly the same as if you were writing a native application. You also get a lot of built-in developer tools. If you're used to Chrome debugging, for example, you can use debugger, logging, things like that. You can even use React and Redux dev tools in React Native. So here are some of the things that are polyfilled from the web. So if you use any kind of front-end framework on the web, you'll be used to Navigator geolocation, fetch APIs, WebGL. You can use any NPM or JavaScript library. I usually use Redux and Axios in my applications. Anything that doesn't touch the DOM is valid in React Native. So anything from the web that you use for state handling or logic or underscore and all those things, anything in JavaScript you can use in React Native. And some things, of course, React Native will do checking for you under the hood. So things obviously display different between Android and iOS. So a lot of the default APIs in React Native, as well as the libraries you use, will do a check, like, is the user using Android? Then render it this way. If it's using iOS, then render it some other way. And that takes into account the differences in both styling and in the user experience of both platforms. So a few reasons why you might want to choose this over regular native development. is cost. So it's expensive to develop native applications because it's a longer time, you're developing two different code bases, and also native application developers are more scarce and they're more expensive. Time to build is also longer, and to be able to maintain two separate code bases is also takes longer and takes more people and costs more. So that's why if you look back, for the last decade, people have been building these hybrid frameworks. There's Cordova, there's so many other solutions. And they fix some of these problems. They have a much faster development cycle. Some companies said that it's 10 to 1. They can do it in a tenth of time as building a regular native application. You can also reuse your same web skills developers. A lot of times you can even reuse the same web views that you used on the web. So if you have a mobile-friendly application, you can reuse those same views. The problem is, and why most top apps in the App Store are still written in native, is that these don't really feel like the same as a native application. So they don't have the same animations, they don't have the same user experience. And so users, even if they're not conscious of it, they can feel the difference between a native and a non-native application. So this is why Facebook actually originally tried something like Cordova back in 2011, and then they said, we can't use this isn't performant enough for our application. And that's where React Native came out of the project. Once they had made React, they had it in mind to, hey, we want to make this a learn once, build anywhere, so we're going to do the same thing we did for the web, making it more performant, and we're going to take that to React Native and mobile. And now it has a huge community and tons of large companies backing it. So how to get started with React Native? The easiest way to get started, if you want to try it out, is there's a website, snack.expo.io, and you'll need a mobile app in your phone called the Expo app. It's a lightweight app. You basically go to this site, scan a QR code. Oh, it's not mirroring. Wait 1 second. Okay, and you scan this QR code on your phone, and you can do it on multiple devices at the same time, and you can then make any changes you want, and it will live update. Oh, I'm queued, I guess, here. So it will live update on any devices and also this simulator that you have on the side as you make changes to the application. And you can use anything from the React Native API in here, and you can also use some things from this Expo team that created this resource. So you can use, for example, a React Native camera module, different hardware APIs, because it's running on your actual device, so you can test out all these things. And actually, before I build components in my application, like once I get designs from a designer, then I actually build all my buttons and things like that in here, so I can see it live updating on both Android and iOS. And then I know if I need to do tweaks on either platforms to how things look. So this team who built this, they also have a desktop application. So you can do it on desktop. And if you've heard of Create React App, it was a way to simplify the formerly infinite complexity of trying to create a React app on the web, where you had to set up all your own tooling, and it was just a real pain to set up an app. So they made it easier. React Native did the same thing. And you can download the Expo app on your phone and their desktop CLI and do the exact same thing that you did on Expo for the web. So it's basically their desktop version of this. The only problem I have with this, and it's that I won't build a whole application because then I can't embed native code or use libraries that have native code in them, which I inevitably do in every project. So I prefer to just mock up my things, Expo for the web, and then write a regular React app. So how to write a regular React app. I want to say harder because I have some background in mobile development, so I already had things like Xcode and Android Studio, but I was trying to, usually I do these kind of talks with only JavaScript developers or newer developers because I teach a local group in Indianapolis, and it's fairly difficult to explain to everyone how to set up Xcode and Android Studio and run emulators. Particularly, I've had trouble with that on Android. So if you don't want to do that, then absolutely create React Native app, and the web application are a great alternative. But these are just the steps that you would have to do. Oh, let me... separate display. Now I don't know where it went. Sorry, 1 second. There we go. Okay. And I think I need to... No, it's not updating. Oops. Okay, so for a project setup, you would basically, after you have, Xcode and all that stuff set up, it's React Native init and then your app name. And what it does is it sets up all your Android and iOS build, and then you would run it on whichever platform. And the unfortunate thing is you can only run it one emulator at the same time because it uses a specific port for both. So another reason why I prefer prototyping things in the web first. So you run it on iOS or Android, and then it brings up this. Okay. So it'll bring up this screen. So it gives you a default boilerplate application with an entry point index.js. So this will render your main file, app.js, and app.js is just a boilerplate which will run on both Android and iOS. It shows you some things, like it imports the platform, so you can select which platform you're on and do different things on each platform. And then it creates your default class and gives you some default styling to get started. So I'm going to go ahead and turn on some dev tools. Command or Control D brings up the dev tools. And I'm just using iOS because this is a new computer. I don't even have Android Studio yet, but it's pretty much the same for both platforms. I can just turn on live and hot reloading by default, and then start to make changes. And they will automatically up. Hot reloading is just really convenient if you're like 5 screens deep in an application, and it'll just patch the code for you and not take you all the way back to the home screen. Generally speaking, you'll be building both. You could set this up in a few different ways, but generally speaking, you would be building both applications, Android and iOS, using the same files and just do checking where you need to. So you'd have a source file, probably drag the app into here, and now it's showing me an error. It failed to load because it's trying to import a module that's not there. Yeah. Oh yeah, so let me just, when I run, I already ran this, so I'm not going to again, because sometimes it takes a minute to start up. So when I run React Native, run iOS, or run Android, then it opens the emulator for me automatically, and then it opens this packager, which will compile and bundle and keep recompiling and bundling changes as I update the application for me. That will also handle configuration in iOS and Android, and there's ways by default that it'll update your plist and your manifest and all that stuff for you if you want to. So another thing with React Native, sometimes it gives you the error, the easier to read error in the red part here, directly on the simulator. Sometimes it gives you an easier to read error in here. They've been doing a lot of work on how they present errors. And generally speaking, I can either find out what it is here, like in this case, let me zoom in, unresolved module app, so I know it was because of the app. This error I really can't read right now. But if I do something like, let me just change this. It should say, oh, it's doing it here again. I guess they updated how they display errors, but it shows me exactly the line and where it is in the code. Sometimes it will be right here, and you can click on the exact file and line, and it'll take you to that file and line and column in your editor to see where it is. So I just have to change it, manually refresh, and it comes back. In a React application, you can also do, it gives you web-like debugging tools by default. So it gives you some instructions here, basically telling you to open the console. So if I want to, this is just warning me that it's running in the background because I have it on different tabs right now. So in my render function, I can do console.log. Message, and it pops up here. I can also use debugger and step through functions. And it will pause my application. So nothing loaded yet. It's going to pause at the debugger and let me step through as it normally would in a JavaScript application. So let me get rid of this. There's a few other ways to log. Let me turn off the remote debugger first. Okay. You can log directly onto the application using console.warn. And this will give me a little yellow non-intrusive error just saying, hey, this is a reminder, basically. And then I can clear these. And there's also console.error. You can throw your own errors. And here's where it shows me app.js, line 24, column 18. This is where the error was thrown from. And I can go to exactly where it was thrown from in my application. So inside this application, what you might notice is there's a lot of styling. So you have to style each individual component. There's no inheritance, there's no bundling a big CSS file separately, which is a little weird at first. Some people don't like it. I think it's a great way to be able to maintain code. When I used to write more CSS, I would inevitably have a lot of things overriding other things or dead code that's not used anymore that's still there. So having it small and inside the component A, makes it so I don't have to set up anything with CSS. I don't have to set up Sass and compile it and everything. And B, it makes it much easier to maintain, so I only have the styles that I'm actually using at a given time in my component. And I'll get into styling components in a second, because sometimes these styles get a little bit long at the file, so you don't want them inside every file. So there's a couple ways of handling that too. So, oops. 1,000. Here it is. Oh, yeah. So how does this work under the hood? It's not compiling to a native binary like something like Xamarin does. You actually have a JavaScript engine running, which is running on the JS core, and then you have another thread, which is your native thread, and that's running code written in Java, Objective-C, C++, which is generally all written for you by the React Native team and other libraries that you're using. And then you have this bridge, which serializes and passes commands and things over the bridge. Of course, that's the slow part of the application. Native is very, very performant. JavaScript is also quite fast. But since it's built on one engine, the React Native team has optimized it quite a bit for using it with React Native. And then another way they make it more performant is they're making React Native declarative. So many of the libraries you use, for example, the animations library, you declare your animations up front in JavaScript, send it over the bridge once, and then all of the user interactions are handled on the native side. So I have an example of that in a second. And some libraries, like React Native Navigation, which is open sourced by Wix, that's also written entirely in native, so you do the same thing declaratively. You say, this is how I want the navigation to look and feel in JavaScript, and then it's all handled on the native side, which actually allows you to make it feel like it's an actual native application versus a JavaScript application. There are also things written in JavaScript. Of course, the code that you write is probably going to be almost entirely in JavaScript. And then some things from the React Native team, some things that don't need quite as much performance. If you have a small list, for example, you don't need to hide things off screen. This is written entirely in JavaScript, and you don't feel a performance hit. And there are some libraries that have a mix of native versus JavaScript, or some combination of both. I used to use a non-native navigation library, but I felt like there was some jank when there were certain animations and bounces and things, so I started using React Native navigation, and it worked a lot better for me. So styling components, like I showed earlier, there can get to be a lot of styling in a single application, which is kind of annoying. So a really good way that I've found to handle that is, so you have your components directory or something wherever you put all your components, and then I have specific components that I usually build up front, like headers, buttons, things like that are the most basic examples. It depends on the project, of course, and then I'll go ahead and make a wrapper. I'll just show this in code for a second. So here, for example, I have a styled button. I have all these styles associated with buttons that I want to just pull in and reuse throughout my application. So all I have to do is pass in the text for the button, and then an onPress function. How do I want to handle the button click? And then I can reuse this component wherever I want without having to copy new styles everywhere. And I also do this a lot of times with component wrappers. If I'm going to have container styles, I'll just do all my styles in a container and then pass in the children components, and then they'll be inside that styled container. So yeah. Another thing that's nice is certain things you want to look different on Android and iOS. So you can have, for example, a button.ios.js, and that will only be used in an iOS application. So you can just import button from button. Let's see if I have an example. This. Here it is. So here I'm importing temp. I'm just writing temp, and then it automatically sees, oh, there's temp android.js and temp ios.js. So for Android, it's only going to use the temp Android, and for iOS, it will only use the iOS by default, which is kind of nice. So that's helpful for styling, because that's really where I need to differentiate most of the time between, besides small nuances and things like there being different keyboards and stuff, most of the time I'm differentiating based on style. So it's nice to be able to have two usually almost identical style components, but just small differences between Android and iOS. You can also do this for checking what platform. So if you want different styling between platforms, you can do that in a single component and just import platform from React Native. And then for iOS or Android, you'll check, is the platform OS, is it iOS, then do this. If it's Android, do that. And platform.select for iOS, I have it setting you are using iOS. For Android, you are using Android. There's also a library for Windows phones that you can, no one's ever asked me to build a Windows application, but if you want to build a Windows application, there's an extension for it. There's also checking under the hood, so a lot of libraries that you use, like this date picker, will show up being a native date picker in iOS, and the native, the little calendar view they have in Android, and the clock picker, which is just a library doing this under the hood and using React Native APIs. So it's checking, hey, what platform is this? Use this React Native API. If it's the other platform, use the other one. You can also use React developer tools like I mentioned before. You just install it, npm run devtools, and then this is from the GIF from the GitHub repo. But so you can basically scrub through it as you would on the web, see all the different components. You can see the props and state associated with those different components. So this is a great tool for debugging state, for updating things on your application. It will live update on the phone screen, which you can also use with the inspector. So let me just use the inspector real quick. There's also an inspector, which has some Chrome-like features. You can tap any element here, so I'm just going to tap the heading. And then it shows me if I have margin or padding associated with it. It shows me where it is located in the application, and I can kind of click through. This is just an Objective-C native UI component that it renders to. So it shows me the font size and margin and everything. I can see all the styles associated with it. If I'm using the remote debugger tools, then I can also update those styles as I would, but you can also do that in the code editor. It's the same thing. Yeah. So debugging, I already showed that. This is one of the coolest or most useful features that you can embed your own and other people's native code. And React Native provides a pretty easy to use native API for it. You will, of course, have to know Java or Kotlin or Objective-C or something to be able to write native modules. And then you just use a wrapper, and you can call these components that you make in native code from your React Native code. And I put links to both the docs because they have two really good examples of how to do that in the docs for Android and for iOS. And then here's an example of how to use other people's native code. So if you're using maybe a hardware API, a new font, or something like that, you'll inevitably have to update something in the plist file and in the XML. So instead of having to do that manually, most libraries I use now in React Native will do that for me. All I have to do is install the library I want to install via npm, and then use React Native link, which handles the configuration for me in the native code. So I can use all this native code without actually having to write or configure it for myself generally, unless I have to update permissions or something. Okay. There we go. So, why is it? Oh, it thinks I'm writing in HTML, so it very nicely added a closing tag, which I didn't want. So this is a web view. If you already have, maybe you have a mobile web application and you want to reuse some of the screens, maybe you're transitioning, this is a really good way to kind of slowly build React Native into what you already have. So you can use a web view, and oh, this is really, it parsed this really weird. I'm using Reveal.js, and it's doing this. Oh, wait. So anyways, all this is right here is, oh, wait. So I need to have a URI, which will be something like github.com inside my source, and it will display inside whatever container or the whole screen or whatever container I put it in. It will display the entire web page, and I can interact with it normally as I would on the web, and that will be displayed inside my application. So if I have a lot of web views already and I want to make some in React Native, reuse some from the web, or maybe I'm building an application where I need to embed web pages into the application, I can still do this. The only thing is then you will have the same performance issues that you have with using traditional hybrid applications, because you're using web views again. Oops. Another cool thing you can do with React Native, because it's built on JavaScript core, is push over-the-air updates for maybe you have a bug fix or some kind of small new update that you want all of your users to have. They won't have to download an update. You can push it without getting approval from the Apple Store, which could take a while. It's variable. And you know that all of your users will have that specific update. You cannot use this for hardware APIs. You're not supposed to make huge breaking changes with this, but it's a very good feature. And you can sign up for free. Microsoft has a very good one that's always free, but there are others available too. And here's some of the companies using React Native. These are the three biggest ones. Facebook, of course, Airbnb, and Wix. They all have a ton of great talks online. They open source a lot of modules written in native code for me, which is awesome, because the more I use React Native, when I started using it maybe 2 years ago, Android wasn't 100% ready. It was out there, but you couldn't use a lot of the same features on iOS because they've spent so much energy building all these things for their huge user base. Then they open source all these native modules, and then you can just npm install them and React Native link, and it's working in your application. Walmart is also using it. They said they get about 96% code resharing between platforms, which is awesome because they have millions and millions of users. Bloomberg, Skype, these are two large applications as well. Tesla. It's a really nice user experience. Discord is one of my favorites. They've been using React Native for years now. They first came out with iOS. About a year later, I think, they came out with their Android version in React Native. It's so smooth and so native feeling. Before I read their blog post, actually, I had no idea that it was built in React Native. So I want to actually, I'm going to close this editor. I'm going to show another application real quick. Let me see, 40 minutes. So to open or to run a new app, I have to terminate not necessarily the simulator, but I have to close the bundler, the React Native packager. And then I can React Native, oh wait, let me clear this. React Native run iOS. This is just a dummy application I built a while back. If you haven't heard of parkour, it's a sport. Let me put this over here with the code. It's a sport that some people do. So basically, I used this back when I was playing around with the animations library. You can spin, bounce. I didn't have the dragging here, but you can actually drag and drop, and it's all very, very smooth and performant in React Native. Here's an example of the same date picker. Sometimes the emulator is janky, but it's never janky when I use it on an actual mobile application. And then I have an events list. React Native has default ways. You know, for the web, if you're loading like thousands of items, you want to load them incrementally, only what's on the screen. React Native has some really nice APIs that do that by default with various types of list views. So you can either render them all at once, or if you know you have a variable number or perhaps a lot of something, you only render what's on the screen, which also helps a lot with performance. Another great thing is using fonts. So for some reason, years ago, I used to have trouble putting custom fonts in. But with React Native, I just tell React Native where my assets are, and then I just run React Native link, and it sees that this RNPM configuration is inside my package.json, and then it'll set up the fonts for me. So you can see, like, this is a custom font. And by default, you get, like, I don't know, maybe 80 fonts with iOS, but you only get, you know, Roboto and serif and sans serif and type something in Android. So a lot of times I will use a different kind of font, and I'll just put the font file in a folder, use an RNPM configuration, and then link it, and it's all set up in my project to use. And I'd use it exactly how I would on the web. I'd use font family and all those other things. The difference, let me pull up. The difference is, of course, all the styling is JavaScript, so it's camel cased. It has to be valid JavaScript because it's a JavaScript object. And of course, you won't have things like hover and other things from the web. So there are some differences. Flexbox is handled pretty much the same, except it defaults to column instead of rows for the web, which handles mobile development, but you can reverse that too. Yeah, and a lot of these things are the same that you would use on the web. Let me see what the font is. Yeah, here's the font family. It's called Frihole. So, yeah, there's a few things like, emulator crashes and a few other things, which I found when I used to do mobile development too. But whenever I do run React Native Link, usually I'll have to restart the packager because it'll throw some random red error that's unreadable, but you just know, okay, well, I put some native code, it wants me to restart it. And yeah, it's kind of annoying that I can only run one simulator at a time. Those are the two most annoying things. And here's my workflow example. Generally, I will get mock-ups from someone else. Sometimes I have to make my own mock-up. There's some great design frameworks like Bootstrap or Foundation, but for mobile. And I have links to those on the next slide. And if I can use one of those, all the better. And then I create reusable components using snacks in the web. And I'll put them inside either a styling folder or a common folder. A lot of times I can copy paste things from previous projects, not the business logic, obviously, but just the styling. And then I just update it a little bit between projects. I can even copy paste a lot of my code from the web and just change it to render to mobile APIs instead of using things from the DOM. Also, my entire Redux setup is just copied from the web. It's exactly the same as I use. And then I plan the folder component structure, set up ESLint, stuff I do for any project anyways. And yeah, and then I start building. And it's pretty easy because it gives me most everything by default. I do have to install React DevTools, which I always install too, React and Redux DevTools. And here are some links that I find helpful. My favorite two styling kits for React Native, and then Expo. Oh, it used to be called Sketch. It's now called Snack, snack.expo.io. I'll fix the naming before I post it. And then if you want to learn styling in React Native, there are two really fun games you can play to learn Flexbox. And it's actually quite easy and intuitive to learn how to lay things out in Flexbox. And you can also practice it with this cool GitHub library called katas. It gives you all these different practices for seeing how to lay out things. If you want to learn more about React Native, these 3 ways are the best that I've found. The Facebook Developers channel on YouTube gives a ton of great content and all the React. You can go to their videos and search for React Native, and they have all the talks from different React conferences and things. Tal Call, he's my favorite React Native speaker. He's been a huge proponent of it for years now. He recently gave a really good talk about performance in React Native, which is 28 minutes long, and it's definitely worth watching. And then there's React Native newsletter, which I have here. So every month, you'll get a newsletter, assorted good things, basically different cool things in the React Native community, events, media, and this is a great way to stay up to date pretty easily. Spend a few minutes scrolling through this every month or so and see all the updates. This is one I'm excited about, AWS Amplify API for React Native, since I use AWS a lot. Yeah, so that's the newsletter. Here's another cool thing that I forgot to show earlier, but people have built lots of games in React Native using the increased performance and ease of building over native. So this guy built a Minecraft setup, which is awesome, and he actually gives a tutorial here on YouTube for how to do it. And you can see there's some really difficult things that you wouldn't be able to do in traditional hybrid, like this gradient and everything, which is kind of difficult to do, but because you can use the underlying native gradients in React Native, then it actually looks really cool. Yeah, so here's my information again. Do you have any questions? Yeah.
What's your experience using native packages like Cocoa Pods and so on?
Like what?
Cocoa Pods. So if you have native packages from app for iOS, so usually when you run native iOS development and importing them here, should you use from React Native?
I haven't used one that someone else didn't already import to React Native, but I'm guessing you just use, because any native code you're going to have to wrap in the native wrapper for React Native. So you can pull in that API and just wrap it in that and use it as normal. Yeah?
Can you connect the debugger to an actual device? Instead of an emulator, can you use the actual device for debugging?
You can, if you use Expo, it will show your logs on the device. I don't know, because I test hardware APIs on my device, but I don't see the logs on my computer. So that's a good question. I'm wondering how I should do that. Okay, thanks for coming.